Okay, hello Cloud Gurus, and welcome to the end of Section 5. So we're going to do the Section 5 summary. I'm going to summarize everything you've learnt in this section. In the next section, we'll take a look at VPCs. After that, there will be a look at Cloud HSM. The Cloud HSM section is optional. I would recommend it if you plan on working as a security analyst with AWS, but like I said, it's not a huge topic in the exam. And then we have incident response section, and that's the fun part. So let's go through and cover what we've learnt in Section 5. So the very first thing we learnt about is KMS. It's a managed service that makes it easy for you to create and control encryption keys used to encrypt your data. KMS is integrated with other AWS services, including EBS, S3, Amazon Redshift, Amazon Elastic Transcoder, Workmail, etc., etc. And it makes it easy for you to encrypt your data with encryption keys that you manage. So you don't have to worry about Amazon managing them, you can manage them yourself. The keys consist of a customer master key. The customer master key consists of a various number of different points. So we've got the alias, which is the name, the creation date, when we created it, the description, the key state, whether or not it's active or suspended or is marked for deletion, etc. And then the key material. Now the key material, either you can provide it or AWS provide it. We did it both in the labs. And remember, the customer master key can never, ever, ever be exported from KMS. That's really important to remember. So there's two types of customer master keys. There's one where AWS manage it, which is what we started with, or you can have customer managed customer master keys, which is what you generate by providing AWS with the key material, which is what we did with OpenSSL in our lab. So to set up a customer master key, we went in and we created a name and a description. We chose our material option. So if we wanted AWS to manage it, it was fine. If we wanted ourselves to manage it, we had to provide the key material detail. We then went in and we defined who had administrator permissions for using this key, so who can actually go in and make changes to this key. And then we went through and we defined who can actually go ahead and use this key. And that is both of those are based off both IAM users as well as roles. And just remember that in terms of our key material options, you can either use KMS generated key or you can use your own key material. And that's what we did in the lab. We imported our own symmetric 256-bit key, which we created using OpenSSL. And we use that to create our own customer master key that we manage. Do keep OpenSSL installed on your computer because we will be using it in the Cloud HSM part of the VPC section of the course. So why should you import your own key material? Well, it proves that randomness meets your requirements, so it can be a compliance element. We are going to have a look at how we can generate randomness a little bit later on. For our Windows users, we actually created a whole bunch of randomness when we were generating our key by moving our mouse around in PuTTY Keygen. Mac users, you didn't see that, but you can create randomness when generating your keys. It makes your keys much, much stronger. You can also extend your existing processes to AWS, so these might be your corporate processes. You'll be able to delete key material without a 7 to 30 day wait, and then you'll be able to import them again. And to be resilient to AWS failure by storing your keys outside of AWS, don't forget that they'd have to lose an entire region in order for the KMS service to go down. In theory, they could rebuild that region, but you have to have access to your key material. We also then went and learned how to import our own key material. So we created a customer master key with no key material. We downloaded a public key, which is a wrapping key and an import token. We then went ahead and encrypted the key material, and we then imported the key material back into KMS, which generated our customer master key. And considerations for importing key material, just remember that your availability and durability is different because you're going to be responsible for making sure that key material is safe. Secure key generation is completely up to you. So how did you generate that key? What methodology did you use? Did you go to a website and do it? You probably never want to do it on a website because you don't know what it is they're going to go and store. For that very reason, you should use something like OpenSSL. There's no automatic key rotations with KMS, and then remember remember that ciphertexts are not portable between customer master keys. So by that, we just simply mean that if you encrypt something with a customer master key, you cannot decrypt it with another key. You have to use the same key to unencrypt it, which makes perfect sense. So we then went on to learn that we can use KMS to encrypt EBS volumes, but we cannot use it to generate public keys and private keys to log into EC2. Remember that KMS is basically symmetric, so you only ever have the one key to encrypt and decrypt, whereas when you're logging into EC2, you have a private key and a public key that's asymmetric. So KMS cannot do asymmetric keys. If you need asymmetric keys, what do you use? Cloud HSM. We can't import or export keys into KMS or out of KMS. We can import public key material, but KMS still helps us generate those public keys and private keys. So for that reason, we can't use it to log into EC2. What we can do though is we can import public keys into EC2 key pairs. So we generated our own ones using OpenSSL, and we then imported it into into EC2. But we also learned that we cannot use EC2 key pairs to encrypt EBS volumes. We have to use KMS or third-party applications or tools. We then learned that we can use KMS to encrypt EBS volumes, and it's possible to encrypt root device volumes. It was a bit of a process there. We basically had to go in and create an AMI. The initial AMI was unencrypted, but we then copy it, and in doing so would encrypt it. And then we could change encryption keys from Amazon managed keys to customer master keys on our EBS volumes. So we could go in and do that. And we could copy from one region to another, and we can make those copies encrypted, but we have to use the keys in the destination region to do the encryption. So if I'm in Ireland and I want to copy it over to Northern Virginia, I'm going to have to use the encryption keys in Northern Virginia in order to encrypt it in that new area. And that's a reminder again, IAM is global, but the actual KMS itself, the keys are stored in the regions in which your resources are. So your keys are locked to a region. You can't take one key and move it to another region, at least not just yet. In terms of SSH, so we can view the public keys by going to /home/EC2user /SSH/ and then this file called authorized keys. We can also view the public keys using the EC2 instance metadata. To do that, we just did a curl to http 169.254.169.254/latest/metadata/public keys /0/open/SSH key. I'm sorry, I know it's annoying, but you do need to know this for your exam, honestly. You can have multiple public keys attached to EC2 instances, which is what we went ahead and did. And you can now add roles to existing EC2 instances as well, and that will take effect immediately. So you can suddenly add the admin access role to S3, and you'll be able to suddenly just go in and query your S3 buckets, which is really cool because you don't have to. It used to be that you had to go in and provision a new EC2 instance and attach the role then. In terms of deleting a key pair in the console, that won't delete it from the instance itself or from the instance's metadata. If you lose your key pair, whether it's public or private, the easiest way to restore it is, to restore your EC2 instance access is to simply take a snapshot of the EC2 instance and then go ahead and deploy it as a new instance. This will then append the new public key to the home authorized key file. It won't go in and delete your other public keys. So if you wanted to go in and delete those public keys because you're not sure where the private key has gone for whatever reason, you can then go into that file and delete the outdated public keys. Remember, you cannot export keys from KMS, which is what I've already said, because Amazon's involved in the generation of keys. You cannot use KMS with SSH for EC2. You can do this with Cloud HSM because you can import and export keys from Cloud HSM. I'm really looking forward to the next section of the course because once we've built out our custom VPC, we're going to go in and deploy a Cloud HSM device inside that VPC. We'll then use that HSM device to go in and generate our keys, which we can then use and attach to EC2 into SSH. In terms of the AWS Marketplace, just remember that you can purchase security products from third-party vendors on the marketplace. These can be things like firewalls, hardened OSs, WAFs, antivirus, security monitoring, etc. In terms of what you pay, it can be any kind of billing model. So it could be free, it could be hourly, it could be monthly, it could be annually, it could be bring your own license, etc. And then just remember that the Center for Internet Security has a whole bunch of OS hardening guidelines. Go ahead and download those reports. You probably won't be tested on them, but you really do need to know that if you're working in the security industry as well. If you want a level 1 CIS hardened operating system, go to the AWS Marketplace and purchase one. That's probably the easiest way to do it. In terms of AWS WAF, at its most basic level, it allows you to do 3 different things: allow all requests, block all requests, except for the ones that you specify, and then, of course, count the requests that match specific properties that you're searching for. So you may have some new types of data coming in and you're not sure if it's good or bad, so you don't want to block it, but at the same time, you're not sure you want to allow it either. So you go through and count it and monitor it that way, and then if it does turn out to be malicious, you can go through and block it. In terms of the protection that WAF gives us, it uses conditions that we specify. We can define these conditions, and we can define these as things like IP addresses, countries that the requests are originating from, values in the request headers, strings that appear in the request when we talked about query string parameters, the length of the request, and of course presence of SQL code that's likely to be malicious. So this is SQL injections or of cross-site scripting as well. So we can WAF protects us in quite a few different ways. Don't forget that WAF also integrates with application load balancers. It does this at a regional level. CloudFront does this at a global level. So you can integrate your web application firewall with both your application load balancers as well as CloudFront. You need to associate your rules to your AWS resources and enable to make it work. If you do associate your rule to a CloudFront distribution, it is going to basically redeploy the distribution. So you're going to have a little bit of downtime. Just be aware of that. Probably 10 or 15 minutes while WAF associates itself with it. You can use AWS WAF to protect websites not hosted in AWS via CloudFront. All you do to do that is you set up a custom origin outside of AWS, so maybe a web server that you've got hosted on Azure, for example, and then you can use WAF to protect that server as well. And then IPs can be blocked at a /8, /16, /24, and /32 level, and IP4 and IP6 are both supported with WAF. We then looked at Shield. We're going to have a whole section on DDoS mitigation coming up. It is turned on by default. If you want the more advanced option, it's going to be $3,000 a month, and the advanced gives you an incident response team that you can, talk to, as well as in-depth reporting on incidences. And the great thing about it is you won't pay for the resources that are consumed if you're a victim of an attack. Moving on to dedicated instances versus dedicated hosts. Both have dedicated hardware, obviously. Dedicated instances are charged by the instance, whereas hosts are charged by the host. You're going to get scenario questions and we'll basically try and trick you and say, where are you going to use a dedicated instance versus a dedicated host? If you've got special regulatory requirements or licensing conditions, such as Oracle or VMware or something like that, you should choose dedicated hosts. Dedicated instances can share the same hardware with other AWS instances from the same account, not from other accounts, but just from the same account that are not dedicated. And dedicated hosts give you much better visibility into things like your sockets, the number of cores available, your host ID, etc. Moving on to the hypervisors, you want to choose HVM over Paravirtual wherever possible. PV is isolated by layers. The guest operating system sits on layer 1, the hypervisor sits in layer 0, and the applications sit in layer 3. Only AWS administrators have access to the Xen hypervisors. AWS staff obviously do not have access to your guest operating systems, such as EC2. That's your responsibility as a customer. And then all your storage and memory is scrubbed before it's delivered to you. So that is it for section 4. You've done really, really well. Let's move on to section 5. And this is going to be by far the most complex section because we will be dealing with VPCs. Again, I say this for every exam, whether you're doing associate, specialty, or professional. Some of the key ways of passing an exam is to know how to build a VPC inside out by memory. And we're going to further complicate it by building out a HSM cluster, and we're going to provision some hardware security modules and then go into these ones. We're going to create a bunch of different users, and then we're going to go in and create our own keys. So it's very, very hands-on in the next section. It's going to be lots of fun. So if you've got the time, join me in the next section. Thank you.